Okay. Good morning, one and all. I, Mr. Mahesh Wagmare, welcome you all with a pleasure on second day of IEEE Pune 2025. On behalf of International Institute of Information Technology and IEEE, we are happy to have our keynote speaker, Dr. Ketan Kotwal, on the topic Rising Threat of Deepfake. I would like to give some brief introduction about the speaker. Dr. Kotwal obtained MTech and PhD from Indian Institute of Technology, IIT Bombay, for the doctoral research on hyperspectral data visualization. He received the Excellence in PhD Thesis Award from IIT Bombay and the Best PhD Thesis Award from the Computer Society of India. Dr. Ketan Kotwal is a researcher at the IDF Research Institute in Switzerland, where his work primarily focuses on biometric recognition systems, including face, fingerprint, finger vein, and the gate-based modalities. His research emphasizes enhancing the robustness and security of this system, particularly in detecting presentation, attack, deepfake, and other forms of synthetic media. He has also published actively on fairness and demographic bias in biometric recognition. He has also organized a workshop and technical event primarily around biometric and deepfake. In addition to the academic research, Dr. Kotwal has provided research and technical consulting to startups in computer vision and machine learning. Thank you. Now, I would like to request Dr. Ketan Kotwal sir to start his session. Over to you, sir.
All right. Thank you, and thanks everyone for being here. I wish I could have been in person, but since I'm not in Pune right now, I will be giving this talk online. And title of this talk is A Rising Threat of Deepfakes. So without any further ado, I'll get started. To begin with an introduction, so many of you have heard this term of deepfakes, but you may not have very clear idea of what it means. So deepfakes are basically a synthetic media where an object in the picture or a video is replaced using somebody else or something else, and most likely it is a person, or even further it's mostly somebody's face or facial expressions. Now this term deepfake is quite new. I mean, it's not very old, right? You haven't heard this 15 years back. And this term came as basically some user on Reddit in around 2017. He was posting this AI generated face swap videos, and he just called it deepfakes, and this is how it got the name. Speaking technically, these synthetic images or manipulated images or videos are typically generated using some of the recent deep learning techniques such as like autoencoders or GANs or diffusion models. And the idea is to create a fake or manipulated video or audio or speech which looks as good as the real one, so it makes it indistinguishable from the real data. Even in the research community, there's a lot of attention this topic has garnered over the last few years. So just to give a look, just to give you some hint, if you look Google or if you find some of these research databases, the number of publications in the top venues catering to the topic of deepfake research have literally skyrocketed over last like 7-8 years. 2016 it was probably less than 10 publications, and now you have close to 500 publications a year, out of which a certain section is devoted to detecting deepfakes, and some certain section, let's say less than half, is devoted to how to generate this kind of data, not to create trouble, but to enhance the research. Well, like now, as I was introduced, you know that I work in biometrics, basically, which is like face recognition and recognition using different modalities. So just to let you know, like how I am connected to, or how my group is connected to the deepfakes. So deepfakes are created to have a realistic appearance of a person or a face of a person, while biometric recognition is to see whether two face images are belonging to same person or they are different persons. Now, whether a face recognition system can be fooled by a high quality deepfake, which means if a synthetic image is created for some celebrity or some politician, can we put it through a recognition system, and the system might not be able to figure out whether it's a person is a real one or it's a synthetically created image. This aspect is also known as vulnerability of the recognition systems. And one of the initial works in this area, which was about assessing the vulnerability, just to make sure at how deepfakes can pose a threat to biometric recognition systems, that was done from our group. And here are some of the results. So I will not get into details, but the green part that you see are the scores of the matching entities, which means that the two persons, if the two images are belonging to same person, you get the green scores. If those images are of different people, you get those blue ones. And you can see that green and blue are well separated, which means we are able to tell whether same person same or different. But if you look at the gray score distribution, which is like leaning towards the real ones, these are the scores produced from the synthetic or manipulated deepfakes. And that too, this was like published 7 8 years ago, so it was still low quality. What I intend to tell you is that even with low quality deepfakes, the face recognition system was getting fooled or was tricked into thinking that its image is as good as a real one. And this is how the topic got some kind of a seriousness. Now I would like to show you some examples of deepfakes. You might have seen this before. And well, I'm going to play YouTube video. I hope you will be able to listen to the video as well. Because of some setting issues at my side, I'm not sure if it's going to happen. But if not, you can look at the YouTube. It's the public video. So this video belonging to Barack Obama, which is not actually Barack Obama, it's a synthesized video. It was created in 2018. This was meant to...
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, I don't know, Killmonger was right, or Ben Carson is in the sunken place, or how about this? Simply, President Trump is a total and complete dipshit. Now, you see, I would never say these things, at least not in a public address. But
are you able to listen to what he says?
Someone like Jordan Peele.
All right, so I'm not sure if you were able to hear the content, but it's basically Barack Obama's fake video where he is saying a lot of random things which he is not saying in real. It is a synthesized one. If you could not hear it, please go on YouTube and see this video. There's also another video which was on TikTok, and it's a deep fake of Tom Cruise. And it was generated using a company or app called Deep Face Lab. So I would just like to show you this video. Even if you don't hear it, you can see like it's a fake Tom Cruise, which is basically falling on the street.
Oh, it's just it's a little embarrassing, you know. It reminds me once in Russia, I ran into Gorbachev. He said, "You know, Mr. Movie Star, are you nervous?" I said, "No, Mr. Gorbachev, I'm not nervous." He goes, "Well, remember how much a polar bear weighs." I said, "Polar bear?" He said, "Enough to break the ice."
What's up,
Well, so it was not real Tom Cruise, but an actor was playing. There was some different actor who is like an impersonator, and they synthesized Tom Cruise's appearance on it just to create that fake appearance. If not, again, you can go on YouTube and search for fake Tom Cruise. There's another video which was making rounds a couple of years ago, especially in the light of Ukraine-Russia war. So it was a fake video of Ukrainian President Zelensky, and it was done by creating some kind of a lip sync. Initially, it went viral, but immediately then it was reported by the government and social media that it's a fake and don't be misalarmed. The reason I'm showing this to you is to let you know that it's very easy to create this kind of deepfakes and spread misinformation, and which is why it's also important that we are vigilant and we have better ways to detect and keep ourselves safe. Another example of deepfake is now this is in the voice. This is not in terms of video. So you can. So Joe Rogan is a podcaster, and using an AI generated voice, which is like a synthesized voice, he interviewed Steve Jobs recently. Basically, his interview with Steve Jobs was published or was synthesized, created. I think more than 10 years after Steve Jobs' death. So this video is created by synthesized speech and cloning the voice. And there's this company called Play HD. And the script was generated using ChatGPT. Well, and having said that, deepfakes or synthetic media is not a bad thing. There are lots of positive applications as well. Many of them pertain to education and training. You can create a lot of realistic simulations, safety drills, especially where human interaction is a bit difficult. Another strong application area is entertainment and creative media, where it comes to de-aging actors. Probably you have seen this in a lot of Bollywood movies as well. It's also helpful in dubbing the movies in different languages, where you typically, when dubbing happens, you see some mismatch in the lip sync. Obviously, people are speaking in one language and other language is being spoken. It's also helpful in creating a lot of privacy protection related data, where you do not want to reveal the actual information or actual face or sensitive information. So there are a lot of good applications as well. However, today's talk I will mostly focus on the troublesome factors. All right. So with this introduction, now I'll get into some technical part, and I will discuss how the deepfakes are being generated, and I'm going to focus on. I'm going to quickly take you from for the different aspects or different techniques that came up over last decade. So one of the simple techniques is called as face swapping. Now, face swapping techniques existed even before deep learning, but people used to do it in a very crude way. So in face swapping, what happens is you take face A, which is the face of a real person. You find the facial landmarks. Facial landmarks are the key points such as eyes, nose, lips, mouth, etc. And you replace those key points by another person's similar key points. And then subsequently, you do some blending so that image doesn't appear unnatural. Now, while this was being done in a bit crude way, some of the initial works using deep learning based methods came up around 2016, 2017, which are called as which the methods are called like face swap GAN or deep face lab. So what they do is you take a face, put it through an autoencoder or autoencoder to have what is called as latent representation of face A, which means a compact representation which is agnostic to the illumination or pose variations. And then you pass it through a decoder, where decoder is supposed to take the latent features and generate the face image. However, you do it on the decoder which was trained for somebody else. So the appearance of the face will become like that of face B. These are relatively simple techniques, but yet quite effective, especially when you do it on the single frame. But you can notice that we were just replacing the landmarks in the first case of techniques. A bit more sophisticated version is known as what is called as face reenactment. Reenactment means you are trying to create the facial expressions of the person's video while creating a synthetic video. So here what you do is you take a video, then frame by frame you do 3D tracking of the facial features, because when people are speaking, people are having expressions. Then there are dynamic movements of mouth and eyes, and the whole face has different appearance based on what people are expressing. People are happy, people are shouting, people are sad. So you find out those expressions and try to map the expressions of the source video to the target video. Which means if the person in the first video is happy, you try to make that other person's face as well, which is like appearing, showing happiness. And because it's a video related topic, when people are speaking, you see significant movement in the mouth area. The common area that gets modified during speech is the mouth. So you look at the mouth regions and you try to emphasize on that region for these expressions, and then you have the modified target or the modified video. This was done by a company or the app called as Face to Face. Some advancement came in terms of from the graphics community, where you are talking more about rendering a texture, because finally face is key points are followed by texture. So here what's being done is you take the source video. Source video is the person or the video whom you want to modify by the target. So target is what is being seen finally on the screen. So from source, you obtain the face geometry, because you do not want the face to appear like somebody else. And you also catch the expressions. And based on this data and the identity information of the target and background is the actual background apart from the face. For example, in my case, right now you see some library. So the information of identity of the target and the facial appearance or geometry and expressions of the source are combined to find out the texture. And there's this neural network, which is like the technique is called neural textures, which is used to synthesize a new texture. And this texture is blended with the background of the target video to create the synthetic video. Well, so far what the techniques I showed require a lot of data. You require a lot of data from the source as well as the target. You require source video so that you are aware of their complete facial structure. But then now came new techniques, let's say around 2020, which said that, hey, if we have a single image or very few images of the source, can we still create a video out of them? Or can we infuse that information into target video? So in this case, now a source has a single image. If you look at this top left, the source image. Now this image or few images are being used to do multiple things. Right? First, they are used to estimate the key points of the face, which is locations of eyes and the local geometry. Similar geometry is also being extracted from the target video. Target video is called as driving video, because that is a video where the source image person will be integrated into. Then based on the key points of the video, you perform the motion transfer, so that the motion of the video is is enriched based on the data from the single source image. And this is together fed for the data generator, for the generator, which is going to generate the animated output or the modified video. Now, so far what we have seen is how do we take one person's video out of an image and second person's video and an image and combine them together for as if one person is saying what is being said by the second person. But there is this another type of synthetic media where you create an image of a person who doesn't exist. Basically, you create image out of nothing, so to speak. So this is called as face synthesis. And here, if you look at this one, the schematics, you will not see a source or a target image. So you start with some latent vector, which is an abstract representation of the person's face. Then there is some mapping network, and you create style vector. Style is the different appearances like hairstyles, mustache, or makeups. And these style vectors are fed to the synthesis network, which is also controlled by random noise. Why random noise, or why there is noise as input? Because you want random variations in the faces being generated. And this is typically achieved by StyleGAN and its different variants, StyleGAN 1, StyleGAN 2, StyleGAN 3, which is from NVIDIA. And there was also a website, I'm not sure if it's still there. It's called thispersondoesnotexist.com or something like that. So you have images of people who actually don't exist, which has like a good user as well, where you can put it for anything where you don't have to worry about the privacy issues or data consent issues. And another topic which is quite popular as well in the deepfakes is you don't change the person, but you change the same person's appearance. So here you can see that there is a source image, but there is no target image. So target is only expression or an attribute. And this is used to alter the expressions or attributes of the same person. And one of the most common popular apps is Face app, I guess, where you have your image and it shows how you will look as if you are younger, how will you look as if you're older, or your looks with different hairstyles or attributes, or as in different makeup accessories. So this is also part of, this is not like a deep fake per se, but this is a part of a synthetic media. Well, I have one more example here, but I guess in this interest of time, I will skip it. Well, one second, how much time do I have? Okay, what I will do is I'll probably skip the audio part and I'll just directly go to the second part of video, because I don't think we have too much time.
5 to 10 minutes are left.
Yeah, okay, good. So what I will do, instead of talking on the generation, I will speak more of some slides on the how to detect deepfakes, because so far we are talking about how they're threatful and how to generate. So let me give you some hint on how do we make deepfake detection. Again, the initial work in this area was based on the handcrafted features. What do you mean is you take classical features such as surf, or you detect the eye blinks, because eye blink is one of the things that were missing in the initial swapping based techniques. Or you take MFCC, which are male frequency for the speech part. So you take input frames, generate one of these features, and you just put some of the standard classifiers, which could be MLP but not a deep one, or simple regressor or support vector machines, and have the result of real versus fake. This kind of works were working, providing quite good results on the initial deepfakes, which were not of very high quality. Subsequent work started using CNNs or RNNs. RNN is a recurrent neural network, and which is good if you want to have interactions over frames. So if you have video, typically. So these works were using CNNs or RNNs as a backbone, which means they will be acting as a feature extractor. Which means, like, for a given image or video, you put it through CNN, RNN, you're going to get a certain feature vector. You put it through classifier, and it will make a decision based on the whether it's real or fake. Some other works which came around like 5 years back, those were trying to get separate cues on the spatial data, like which is within frame data, and temporal cues. So temporal cues are the inconsistencies that they were trying to find out over sequence of frames. So here you can see that there's an optical flow stream. Optical flow is a notion of how the movement is taking place within frames. So what happens is when a lot of defects were synthesized frame by frame, you would lose the consistency or naturalness over a few seconds of video. So you get spatial cues, you find out temporal inconsistencies, temporal differences, and then you fuse those features to have the final result. The next set of data started taking care of audio as well. And here what people were doing is you take a video, you also take an audio, and you try to learn the correlation between the lip movements and the audio. So which is basically lip sync. So if you see that lip sync is not very good or it's inconsistent, you can say that the video has been forged. And this is called as lip forensics. The paper is called lip forensics. Subsequently, people used transformers because the transformers showed a lot of capabilities of holding up, because transformers were meant for doing sequential models. So they had intricate capacity of taking care of the relations over time. So you encode the spatial data, and the temporal data is understood over by the transformer, and then subsequently you have the classified output. Most of the videos I showed so far, most of the techniques I showed so far, were looking at a pure video. Now there's another set of methods which talk about the multimodality, so which specifically look at the audio as well as video. So some methods basically take care of fuse the audio and video data. When I say early fusion means fusing at the data level and not at the decision level. So you take audio through a CNN or a transformer, obtain a feature. Same for video, and then you classify the feature for being real or fake. Another set of techniques do not process audio as a pure audio, but they use ASR or automated speech recognition. So the output of ASR is a text. It's like generating subtitles. So here you take a video of the lip region or mouth region, and then you convert audio into text, and you learn the correlation between the lip movements and the text which is being actually spoken by the person, and try to see whether there is a discrepancy or it looks smooth. Recent works are using attention mechanism through transformers. So the simplistic way I could show is take an audio, take a video, and put dynamic modality attention. Dynamic in the sense it's trying to find out at runtime, like if there's an inconsistency, and of course it's generating a lot of good results. Well, this is one of the defects. Again, just to tell you, like these were the images of Donald Trump being arrested, which is not true. These were generated using the stable diffusion and mid-journeys models. Of course, this was done a couple of years back when Trump was not the president. But these images went quite viral on social media, but immediately it was realized that they were fakes. So quickly, I'll go through some future directions and the open problems in this area before we conclude. One of the main challenges is that a lot of work that is being done is still being done on the small curated data sets. We need to have defect detectors which will work quite well in the real world data, which is often of low quality and is often highly compressed. Like you have a small size and a strong compress. Compress is like JPEG kind of data. We need to have methods that should work on real world data sets. The lack of data is also faced on training side. Like there's ample data, but we cannot really label a lot of it. So label data is very less. So how this label and unlabeled data can be used to train the models, and this the one of the major aspect major theme here that can be self-supervised pre-training of the models. Now, if you look at it, for last 10 years, this field has progressed quite a lot, and which means you also need updated benchmarks to make sure that you are evaluating your methods on the latest data sets. And this is why we also need to have create benchmarks or data sets which are evolving in nature, which are more dynamic and up to date. Explainability is a big topic in AI in general, and even here, if we are able to flag some data, if we want to flag some data to be a deep fake or a fake one, synthetic one, it will be really helpful if we can explain why the model has made a particular decision, or even provide some sort of attributes. Attributes here refer to the sort of models that might have been used to generate that data, so that this technique becomes a little more legally addressable. Using multimodality is one of the useful cues, because even latest deepfakes are not doing so well, particularly in terms of lip motion and lip syncing. So one of the ways forward is to explore the multimodality of the data for detecting the deepfakes. And I guess finally, we want things to be working in real time with low latency, because especially if this is happening for surveillance or let's say a video call or conferences, it's great if we can do it at a real time, so that we can flag the trouble right away. All right. So here I will conclude, and if you have any questions, I'm open to that.
Thank you, sir, for throwing a light on a rising threat on deepfakes and exploring various issues regarding the rising threats of the deepfakes in the world. On behalf of International Institute of Information Technology and IEEE Pune, I extend our heartfelt thanks to Dr. Ketan Kotwal for his insightful and engaging session. His expertise in biometric recognition and defect detection gave us a valuable perspective on a cutting-edge research and real-world application. We are truly grateful for the time he spared from his busy schedule to share his knowledge with us. It was an enriching experience for all participants. Thank you once again, Dr. Kotwal, for your inspiring talk, for connecting with us virtually. We look forward to more such interaction in the future. Thank you, sir.
Thank you.